Welcome to classwork 9.3. Today we're studying the law of cosine. So first, just write it down. It's c squared equals a squared plus b squared minus 2ab cosine c. Notice how it's very similar to the Pythagorean theorem. And I want you to notice that these are always going to match. Notice how it's lowercase c and that's uppercase c. So those are going to match. So take a moment to pause the video just to write that formula down, and then unpause once you're ready. Now the main thing to note for this formula, I will do this in red here. These letters are arbitrary. So I like the word arbitrary because it basically means like they're assigned arbitrarily. And as long as you fit the pattern, it really doesn't matter how you use them. So for example, I can actually rewrite this entire formula to say b squared. I could say b squared equals a squared plus c squared minus 2ac cosine of b. I could also say a squared is equal to b squared plus c squared minus 2bc cosine a. So notice how I can pretty much be flexible with these letters as long as they fit the pattern. That's what I mean by arbitrary, that you can have some flexibility when you're working with these formulas. So let's go to the first example. We're going to use the law of cosines to figure this out. So let's draw a triangle here. So again, just draw your generic triangle. A, B, C. A is 2, B is 3, and C is 60. I quickly want you to notice that you cannot use a law of sines here because there is no pair. Okay, so again, there's no pair here. So you currently cannot use a law of sines. And notice how it's side, angle, side. That's what this is saying. I sometimes call this an angle sandwich. That's a big indicator we're going to use a law of cosines. So we're going to try it right now. So I'll write it out for you. C squared equals a squared plus b squared minus 2ab cosine c. Let's plug it in. C squared, which we don't know, is equal to a squared, which is 2 squared, plus b squared, which is 3 squared, minus 2 times 2 times 3 cosine of 60. Now you will have a calculator for this section, but it is helpful to know how to do it by hand. So let's just work that out really quick. If you had a calculator, obviously just plug it all in, but since we can do this by hand, let's try it. 2 squared is 4, 3 squared is 9, minus 2 times 2 is 4 times 3 is 12. Cosine 60 is nice, that would be 1/2. So c squared is equal to 13 minus 6. So c squared must be 7. So look, we found it. C is the root of 7. And if you plug it in your calculator, you get approximately 2.646. Now to make it a little more precise, I'm going to use the root of 7 just because that's a really clean number. And now, notice how we actually can figure out the other angles because, let's highlight this right here. Look at that. By finding what C was, we now have our pair right there. So now I'm going to write on the side, I'll draw a big line here. We're going to use the law of sines. Now notice how there are two choices for A and B. This is going to be very, very important to get these questions all correct. So really put this in red. Use the law of sines to find the acute angle. It must be the acute angle. Now the reason for that is because last class we learned that when you use law of sines, there's some ambiguity as to whether there are one or two triangles. That happens when you're working with sine inverse. So to avoid that issue, we're going to always use law of sines to find the smallest angle. So I'll put acute, or think of it as the smallest angle. So looking at our choices, that means you actually want to find A. This right here must be acute or small. It must be acute. And that's because, look at this length. This length is 2. 2 is much smaller than 3, so therefore that angle should be smaller than the angle B. So we know if we find A, there's going to be no ambiguity. So let's start there. Sine of A over 2, that is equal to sine of 60 over root of 7. Let's multiply by 2. So sine of A is equal to 2 sine 60 over root of 7. We're going to sine inverse this, and we get A is equal to 40.9 degrees. Now remember, last class we always did the or 180 minus this answer, but we're going to deny this. There's no need to do this because we know the angle must be acute. It must be small because look at the triangle. It has to be a small angle. So by doing that, we avoid that need to do that 180 minus the angle to check anything. So I'm going to fill that in now. This is 40.9. So which means the last one must be 79.1. Okay, and that's it. Let's go to the next example. So this is a word problem. It says an airplane flies due north from Fort Myers to Sarasota. So let's start there. We have Fort Myers flies north to Sarasota. Okay, so there's our plane flying a direct line. A distance of 150 miles, so that's 150. Then it turns through an angle of 50 degrees and flies to Orlando. So I'll put that as Orlando, and I'll just connect this. And we're looking, oh, that's 100 miles. And then we're looking for, how far is it directly from Fort Myers to Orlando? So we're looking for this x. Now the key here is understanding this. It turns the angle of 50 degrees. If you imagine the plane right here, flying, the plane's flying up here. So imagine this line of sight for the plane. That would mean if it turns 50 degrees, that 50 degrees is actually right here. It's actually the exterior angle of the triangle. That's 50. Get rid of that. This right here is 50 degrees. Which means the angle you actually want to work with is right there. That's actually 130. So there's our true angle for the triangle. And now we can use the law of cosines. So let's work it out. X squared is equal to 150 squared plus 100 squared minus 2 times 150 times 100 cosine of 130. This is where you get your calculator. X is the square root of all that stuff. I'm going to put a box here. Put a big box. And you get the answer. X is 227.56 miles. There it is. Okay, now B is kind of a cool one. I just throw that in so there's some application. What bearing should the pilot use to fly directly from Fort Myers to Orlando? So this idea of bearing, I'll put a note here. Bearing. It relies on this basic understanding of north, west, east, and south. And bearing is what people, like if you're flying a plane, you kind of use bearing to talk about like how we're navigating. So for example, if I say north 30 degrees west, this means face north and turn 30 degrees to the west. Which means if we're looking north here, I'll do this in red. If we're looking north, we're going to turn 30 degrees to the west. And that would be the idea of how bearing would work. So in this one, it's really just asking for how can we find this angle, then how would we tell a pilot to do that? So to find that angle, let's just use what we've been doing. Use law of sines. We have our pair. We're going to do sine of 130. over 227.56. That should equal this angle, this Fort Myers angle. So I'll put sine of, I'll call that like FM. And that corresponds to 100. Let's multiply by 100. So sine of the Fort Myers angle, FM, that's equal to 100 sine 130 over 227.56. We sine inverse this whole thing, and the angle FM, once you plug in your calculator, you're going to get 19.67 degrees. And again, we're not going to do the minus 180 thing, or 180 minus that, because we know that angle is acute. There's already 130 in there. So there's our angle, and the bearing is just going to be north 19.7 degrees, and it's turning to the east. So that's our part B answer right there.